average rates of change. This is our little initialism for it, okay? We're just going to call it ARC. So that's our average rate of change, is the change in y, and that's what this triangle stands for. So if you guys see it in your textbooks and you're curious what it stands for, it's talking about the change in y, which would be your change in your vertical points over the change in x, which is essentially slope, if you remember from grade 9 linear equations, okay? This is the slope formula. Though they've written it differently, it's the exact same idea, and I used different subscripts here, but it's very similar, or if not identical, to this formula, okay? So it's a formula I learned a very long time ago. So average rate of change is essentially finding the slope between points, but when we're looking for average rates of change, we're usually not working with linear equations. We're usually looking at something that has a curve to it. Okay, so we'll find the average between those two slopes. So the question we've been given, they've given us this quadratic here, all right? And obviously it's not linear, and we want to find the average rate of change between several points in our question. So we'll go back and take a look at it. The very first one, they want to find the average rate of change between 0 and 1. So we're going to talk about how we can put this in to our function and solve these values. So these are essentially our y values, and these are our x values. So the very first one, we're going to set up a coordinate. We know our first x coordinate. We'll call this our x1 and our x2. The first coordinate we're going to be using is 0 for x1, and our f at x1, which is essentially our y value, we need to solve using, I should have written the equation over here, I'll write it in, using this equation we have, okay, negative 5x squared plus 10x plus 120. So let's write that in. Negative 5x squared plus 10x plus 120, okay? So this is our f at x1. So there we go. So we're going to have to plug 0 into this equation to figure out what our y value is. So we're looking at f at 0. Anyone know what it's going to be? 120. Very simple, right? The 0 is essentially going to eliminate everything else that's left over. So our y value, or our f at x1, is 0 and 120. Okay? So we're going to do that again for the second x coordinate. We know our second point. We'll change the color here. Our x2 is going to be our 1 value. And our f at x2 we need to solve. So from our formula above, we're looking at f at 1, which means we have negative 5 times 1 squared plus 10x. Whoops, not x. What is it now? 1. Good. And plus 120. Okay. This will give us negative 5 plus 10 plus 120. What's it going to be? 125. Great. Okay, so these are our two coordinates, okay? And we're going to use our average rate of change, or our slope formula, to figure out the average rate of change, okay? So if you remember the average rate of change, our ARC was written as f at, I think I wrote x subscript 1, but it doesn't technically matter the order as long as you keep one set of points first and the other set second, same as when you guys work with slope so many years ago. So we have our f at x1, which is our y value for that, and x2 minus x1. So we have our coordinates. Let's scroll up just a little here. Don't lag on me. Oh no. Go back down. Thank you. Okay, so we'll take our coordinates and we're essentially going to plug them in. So our f at x2 was 125. So we have 125. That's going to be subtract our f at x1, which is the y value from that coordinate, which is 120, divided by, and our actual x coordinates, our x2 was the value of 1, and our x1 was the value of 0. So for this average rate of change, the division part is quite simple for us. We're going to have 5 over 1. So what is the average rate of change? Just the value of 5. So to kind of show you what those points would look like, I'm going to draw a vertical line at 0 on our point here. And that's the coordinate we got. We got 0 and 120. That was our first coordinate. And the other coordinate was at 1. Let's zoom out a little so I can see that dot. Here we go. And we had 125, okay? So we can actually build using this slope. If we really want it, we could find the equation of a line that would connect those 2 points. The only extra point we would need is the y-intercept. And since this